My name's Andrew Todd. I'm the head of Net Zero Carbon at Sureserve, and we're going to talk to you today about heat pump projects, which are particularly pertinent at the moment because of the latest wave of funding under the Warm Homes Social Housing Fund, which has a bit more of a focus on low carbon heating. So we'll be running through a little bit about Sureserve, because you might not have heard of us as Sureserve, although you probably know some of our group companies. We'll then talk a bit about the Warm Homes Fund itself in terms of the focus on low carbon heating. Going on to then some key considerations for developing air source heat pump projects, focusing specifically on air source heat pumps, given that's one of the priority technologies in the fund. And then we'll be talking with some of our expert installers as well, who'll give their practical advice, and then you have your chance to ask them some questions. So a bit about Sureserve. We are a leading compliance and energy services company in the social housing and public building sector. By compliance, we're talking about things like fire and water safety, gas checks, EICRs, and then energy services. We're looking at installation of insulation, of heat pumps, of other low carbon heating, and solar PV and batteries. So offering that kind of whole house retrofit approach alongside other retrofit services. We are trying to play that pivotal role in housing decarbonisation, so taking organisations from their kind of steady state of using fossil fuels through that energy transition into renewables. We're a major installer of heat pumps. So last year we installed over 3,500 air source heat pumps, which when you look at the MCS data, makes it around 10% of all MCS accredited air source heat pumps. So not an insignificant number there. And then we also offer decarbonisation strategy and funding application support to our clients. So I've introduced myself, the head of Net Zero Carbon, and I'm joined by the people you're seeing on screen. So Finbar, could you just introduce yourself, and then Kevin and Ryan?
Yeah, afternoon. I'm Finbar Fitzpatrick, head of renewables at K&T Heating, part of the Sureserve Group.
Kevin?
Yeah, I'm mute.
Can you hear me?
Yeah, now.
Yeah, sorry, thought I'm wrong there. Yeah, my name is Kevin Long, the install manager at Swell Heating.
Thank you, and Ryan.
Hi, Ryan Stirling, renewable technical manager at Everwarm, part of Sureserve Group.
Good stuff. So, between these guys, you've got multiple decades of experience of installing and then servicing and repairing of heating systems, and that covers everything from that initial kind of concept through to design and specification, and covering both domestic and commercial buildings. So this is your A team in terms of experience of delivering air source heat pump projects. What have we done so far in terms of SHDF? So we've retrofitted over 2,500 homes, and that's covering fabric, covering low carbon heating and renewable energy and battery storage. And we're gearing up to do many more under the Wave 3 funding. So yes, I wanted to focus on what the changes are and some of the specific guidance around low carbon heating in this latest wave, because they are slightly different. So DESNZ have actively acknowledged that they're encouraging applications with low carbon heating, and there's a couple of policy tweaks that have helped them to do so. But the strategic priorities of the guidance notes that applications that install low carbon heating in a significant number of homes will score quite highly in terms of points of strategic fit. But it's worth mentioning that the same criteria as in other waves still apply, in that bills mustn't go up as a result of replacing heating systems, that post-retrofit homes still need to comply with all of the performance outcomes, and that properties won't be eligible for funding for low carbon heating if they've previously had funding under schemes like the RHI or the boiler upgrade scheme. In terms of the grant funding itself then, so you'll have that base cost cap and then the off-gas grid cost cap for low carbon heating. And those can be averaged across homes and measures. So effectively, base cost cap can also fund low carbon heating systems. Combined, that gives you 15k of grant funding, which you'll then match fund with at least 50% to get up to around 30k. And then this round, you've also got this on-gas grid low carbon heating incentive, which is an offer of 20k per home with no co-funding required. And that's for up to 10% of the homes in each application. So bearing in mind, you can't use that in conjunction with the 7.5k cost cap, the base cost cap, and it is specific to those on gas grid homes. But it's that additional mechanism that gives you a bit more funding to play with to upgrade heating systems. If you haven't already done so, I would encourage you to have a deep dive of the FAQs on the gov.uk website, which really go into some of the nuances around how the funding can be used and kind of blended across different funding streams. In terms of eligible low carbon heat technologies, first point is that they must be compatible with SAP. As with any measures going into your your Warm Homes Social Housing Fund bid. And then in priority order, these are the technologies which are eligible. So air to water heat pumps are kind of top of the list in terms of priority, alongside shared ground loops and ground source heat pumps. Then it goes down in priority to air heat pumps, to solid biomass, but only in rural areas, and then heat batteries and high heat retention storage heaters, but specifically just for electrically heated flats and small dwellings. A brief note on hybrid heating systems, because we see hybrid playing a kind of key role in the decarbonisation of homes and acting as that kind of transition technology. So you can use the funding to install hybrid heat pumps, but there's a few caveats to that. The types of technologies, you can either go for a new hybrid system, which consists of several units, so your air source heat pump unit plus your gas boiler, or it can be a fully integrated system in one single unit, or the final one is a heat pump alongside an existing A-rated gas boiler, but only if a retrofit coordinator is satisfied that it's in good working order. And then the caveats. So retrofit coordinators are encouraged to upgrade existing heating systems to standalone heat pumps where possible. Where an existing boiler is replaced with a new boiler, funding can't be used for this. And then hybrid heating system for homes off the gas grid are not permitted. So important just to get those right in terms of your planning when you're looking at which homes might be suitable for hybrids. So I'm going to move on to some key considerations for developing heat pump projects. Heat pump projects, like any retrofit projects, need to be really well planned in order to manage any risks and issues that might occur during the different stages. So you'll need to be clear about your start and end dates for each property and for your whole project. You'll need to plan for access to the homes during the installation phase, and you'll need to conduct appropriate risk assessments and health and safety plans in place, covering both your contractors and your residents. During installation, you need to consider how to get your heavy plant across the site and into its final locations. You'll need to think about the time that residents will be without heating or hot water, and making sure that you've got provisions in place to provide alternatives if this is going to be a significant time period. And then think about resident disruption as well, which could be significant, particularly if there's works going on inside homes. And think about your resident liaison approach from an early stage to make sure your residents are aware of any disruption. And then following installation, making sure that any DNO and planning applications are submitted in good time, and that the future maintenance and repair schedules are considered, including how they're going to be budgeted for and who's going to be responsible for what. It's worth considering permitted development, because typically air source heat pumps can be installed under permitted development rights, but these are subject to certain conditions. So the main ones being that there's one heat pump installed per property, The outdoor unit is no bigger than 0.6 cubic meters, and that is usually the case. But worth checking when you're specifying your heat pumps. That you can't put the external unit on a pitched roof, and that if you are putting it on a flat roof, it's at least 1 meter from the building edge, and that the unit must be installed at least 1 meter from the property boundary. Now, it's worth checking with your planning authority whether or not permitted development does apply in your case, especially given that the requirements can change. I think there's certain changes afoot related to noise assessment and acceptable noise levels, and therefore the installation boundary of properties. So do consider these when you're planning out your projects. So a bit on the location of the external unit, which is not all about satisfying permitted development rules. For optimal performance, you need to make sure that you're installing the heat pumps on a flat, level surface, and then there's good drainage for all the condensate that might build up. You shouldn't install directly below a window of a habitable room. By habitable, we mean a bedroom or a living room, not a bathroom or a kitchen. That's to kind of minimize noise disturbance. And ideally, you should install them close enough to the building so that you're minimizing the pipe runs and any potential heat loss from those. You need to install them with plenty of space at the back and the sides, because this is where the air will flow and heat will be drawn in to heat the homes. And ensure that you've got plenty of good access for maintenance as well. So yeah, access to maintenance is key. Your service engineers will need to take off panels and operate in and around them. So do make sure that they're not stuck in flower beds, as you're seeing on that one on the right-hand side, and that they're easily accessible. I think this is particularly important if the units aren't ground mounted, just to make sure that there is clear access to them. And then thinking about weather, try and avoid direct sunlight where possible, and install it where it's sheltered from the extreme weather, which will just help with the operation, making sure that it's operating well, and it will help to extend the life of the unit and its overall performance. Great, so that's enough of me talking. We're now going to turn over to some of our renewable experts. We're going to cover off each of the main stages of heat pump projects. So I'll start with Ryan, who's going to cover off initial feasibility and engagement, and then design. And I'll start with the question of, at the initial feasibility stage, what should social housing providers be looking for in their housing stock to determine suitability for heat pumps?
So in terms of sort of existing stock, the sort of easy hits, so to say, would be something that's maybe been recently upgraded fabric-wise. Obviously, the higher insulation levels, the better the heat loss, means the lower the running cost. Maybe a sort of mid-band D on an EPC or upwards. Maybe something that's recently had PV and battery installed that can offset running cost. Part of that would be discussing with tenants, so as well, that they may not have a gas bill, say, so their electricity bill would change and be higher, but there's a comparison to be done there. And probably the systems that you're already looking at that would be come towards the end of their lifespan. If a tenant's going to have the upheaval of, say, an upgraded gas system because their boiler's about to pack in, then that's probably a good time to consider a heat pump instead.
That's brilliant, Ryan. And where's the best place to kind of find the data on these from a housing association perspective?
So EPCs will cover a lot of data on it. We can also do a full sort of retrofit assessment of the property that helps consider it. And to be honest, a lot of a lot of the housing associations do tend to have good information on their stock these days. It's well maintained as well, but it's also something we can assist with when required.
Yeah, brilliant. Okay. So looking at the design stage, what are some of the key considerations for heat pump system design that housing associations should be aware of?
Well, you've already covered off sort of location in terms of the noise calculation, but there's also considerations for the refrigerant gas. dependent on the gas in the system, there may be special requirements for siting the units. Noise calculations in terms of neighbouring properties, not just the property itself that's being installed in. There's obviously, you've got to look at an accurate heat loss for the property, an accurate assessment being done, taking into consideration the proper U values of the structure as it is at that time. External design temperatures, so depending where it is in the country, it may be an average external design temperature of, say, -5 in North England, but if you're installing in, say, Wick at the top of Scotland, you'd need to consider a lot more adverse weather conditions, especially in the dead of winter. Your radiator sizes or your internal sort of air unit sizes to be able to cope with each individual room. You need to consider flow temperatures and pipe work. So the lower the flow temperature, the heat pump isn't working as hard, and it's the lower the running cost. And you would need to consider sort of space for buffer tanks and things like that, so that the heat pumps can achieve their defrost cycle in the dead of winter as well, so they're not freezing over. And probably one final part would be a conservation area. A lot of people would back away from a conservation area, but it's not that much different. It just means there's a few more requirements on site in the heat pump, and we need to put it up the back of a garden and then put a building application in for that location. But that's all something that we can assist with or do on behalf of a client.
Excellent. Yeah, conservation areas, it makes permitted development a bit more tricky, doesn't it? And more likely to require full planning permission, but that doesn't mean that you can't do heat pump projects there. Just that point about pipe work as well, because I often hear about microbore pipe work. So do you have experience of installing heat pumps with microbore, or does that usually require a change of pipe work?
So given the opportunity, we would always recommend replacing pipe work. The systems can work with microbore. It's kind of frowned upon in the industry, putting this new technology onto small microbore, because flow rates are so important and carrying the heat load is so important. So if the opportunity is there, I would always say replace. Otherwise, you'd be looking at installing sort of upgraded pumps and things like that to be able to cope with smaller pipes.
Great, yeah. And I think you've touched upon my last question for you, which is about the importance of reducing space heat demand. But talk to us a bit about that. And, I know a lot of these projects, we're now coming to low carbon heating after some of the fabric's been done. But yeah, if you could expand on that a bit.
Yeah. So in terms of fabric, obviously the better improved the fabric is, the more suited it would be for a heat pump. So there's always a solution to help lower that heat loss, and the lower you can get it, the better. In a heat pump, the compressor is what basically costs the most money. It's when it's been fully charged to electricity and it's ramping up and running full time. So the more you can minimise that, minimise the startups and minimise the amount of times it's kicked in sort of per hour, the cheaper it will be in running. So whether that be another 200 millimetres loft insulation, some underfloor insulation, anything at all that can be done to improve that fabric will absolutely be crucial sort of in the end product.
Yeah, and could help to save money on capital costs, not having to oversize heat pumps, and then operational cost as well. So worth the investment in the fabric.
Absolutely.
Great. We'll turn over to Kevin now. He's going to talk to us a bit about resident engagement throughout the project. So Kevin, heat pumps, they're relatively new in the UK, not so relatively new in other countries, but they're likely to be quite a significant change for residents in terms of going from a gas or an oil boiler to a heat pump, and how they control things and how they use them. So what are some of the main differences between those traditional heating systems and heat pumps in terms of how they need to be operated?
Just before I start, just confirm you can hear me, just for my previous problem.
Yeah, no,
good. Okay. Yeah, good. Moving from a gas boiler to a heat pump is going to be quite a big culture change for any resident. I think anybody that's had previous experience with gas boilers, they're quite on demand, boost functionality to them. And as Ryan's alluded to, the heat pumps work much better when they're not cycling, they're not on and off constantly. So education to the homeowner, the resident, is going to be key with this, because what we need to do, we need to educate them that to have it on longer, and it's going to take longer for a property to warm up because it runs at a lower temperature. So it's not kind of an 80-degree gas boiler that's going to heat the rads up very quickly. This is going to be a more slow heat that's going to build up. It's going to slowly heat the area up, and it's just that education from that really as well, and looking at the controls as well. There's so much more technology behind them. So gone on the days with just a basic room stat on the wall. Now we're looking at heat curves and monitoring outside temperatures, and the education is key, that they need to plan for the heat they want. So don't expect it to boost it for an hour in the morning, the house to be red hot. So it's really the education piece behind that, and making sure we provide the right documentation to explain them how to use it, how to set it up, and just explain all that really.
Yeah, that's a really important piece about the kind of controls and how people are engaging with the technology. Have you seen any control systems for heat pumps that kind of mirror what they might be used to in terms of older technologies like gas boilers? What are the kind of controls that you are seeing out there?
It varies really. So they're as complicated as you want to make them. So the easiest thing that we've done for us is we have worked with the manufacturer, set it up as best we feel with the manufacturer's help for that property, and we kind of make it as easy to use as we can for the residents without them affecting too much, which will make it, by them changing something quite simply, may affect the running of it, and it'll be cycling more, and it'll be cost them more money than it gives them. They think it's not working correctly. So it's trying to work with them, work with the manufacturer, and getting that right balance of how it should be set up and left, and the education piece as well, I think, is real key with that.
Yeah. So on the education piece, when is the best time to engage with residents on heat pump projects?
At the earliest stage possible for any retrofit projects. You want to engage as early as possible, so you basically get the trust, because you're explaining outcome's going to be from early on, what they should expect from it. What you don't want to do is after the install and go, well, this is how it works. Well, you didn't explain that to me on the outset, so now they're a bit up against it with the knowledge of it. So early engagement key. I've unfortunately been had to go through some manufacturer's instructions and then complicated, so we set up some quick guides for residents, because it just made them easier to use, easy to understand, just basic explanations, so they know what to expect, I think is really important. Yeah,
so translating the kind of very technical into something really non-technical in terms of the audience, so that they understand, okay, well, it's not as big a change as as it needs to be, and this is how it works. And what are some of the other communication methods that that you might use to talk to residents about how they're going to operate the heat pumps?
So I've been involved in, it depends on the scale of the project. I've been involved in 2 ground source projects that have been shared for a whole block, and we've done resident liaison days. We've done coffee mornings before, during, and after. We've had resident liaison officers on site to run through what was happening, what they expect, the downtime. Planning is really key with this. If you're not honest with what they should expect with downtime or during the installation of larger radiators or larger pipework or the upheaval in there, then they're not going to be very happy, basically. So we've done quick guides, we've done online forums, we have had a manufacturer's van attend site previously, so they have a unit in the back of their van that can be shown how it works, the setup, what they expect to come to their property, what will be installed. So yeah, we've done various things, Q&As. Yeah.
And the more methods of communication, the better, because all residents will absorb material in a different format and at different paces. So yeah, that all sounds great.
And we as well, we've had to do it in different languages as well for parts of London, because not English isn't everybody's first language. So we've done quick setup guides and then done a quick Google Translate on it, and that's been really helpful as well.
Brilliant. Good stuff. Well, we'll turn over to Finbar, which he's going to cover the handover and aftercare or operational stage. So talk to us about the handover process for heat pump projects, in particular, what involvement housing providers will have during that process and when they need to get involved and what they need to be aware of.
I think at this stage, at the handover stage, the good thing for the housing associations or councils is they don't have a lot of involvement at this stage for the paperwork side, and all of our DNO applications or any of our handover packs will be covered all by us individually. So it's more at the start is their engagement. And then the handover process, it's been touched on previously by both Kevin and Ryan. The end user and tenant in our clientele, so in our social housing market, is absolutely key to the handover stage. Their understanding of how their new technology and their low temperature heating system works is probably the most focal point of everything, because it's up until now they've had guided access, they've had everything, and it's until they're, I guess, left on their own with their new system and they try and run it previously. So it's making sure they're fully aware of how the system works, so that how the technology works to start. As it was touched on previously, it's totally separate to your high temperature heating. So that is probably on that side of the handover process is key, is the explanation and that, making sure that the end user is fully aware of how that works.
Yeah. So there's more of a focus on the residents themselves, but housing associations can play a role there in getting them on board and making sure that they're kind of absorbing the information.
So again, as part of that, where we've looked at as Kevin has said, the larger products, the different methods of communication is, we've done often some QR code sets where if we have the similar system in a block of 40 or a road of 40 or 50, we've done some QR codes where we've done a kind of a walkthrough video of the house type. Mm-hmm. And then they're able to kind of see and reference it to, I recognize that because it's very similar to my home. So a lot of it's about familiarity and keeping it like that. So that's been a really helpful tool.
Great, good stuff. And then in K&T, you're providing a lot of service and repair contracts for operational heat pumps, some of which would have been installed by us, others installed by others. What are some of the main issues that you're seeing in operation, and what could be done at either the feasibility stage or design stage to try and resolve them?
Again, I think, especially at the moment, we've got a lot as a predominantly service and repair company. We have quite a large delivery arm, but our bread and butter is service and repair. So we do look at installs at a total different kind of more of a long-term set with our clients, because we know we're going to be looking after them. But we've got a lot on the new build sector coming across at the moment. So they've come across through the housing association or council from their new build department across. I think one of the key things I'm pushing a lot with our clients at the moment is finding out a little bit before the end of defects. Unfortunately, when we go in and we look at these properties at 26 and 28 months, it's too late to pull the defects up for any developers and to help the client. So it's making sure we try and get in on that year one and make sure that there is no defects, which we're all hoping for. But if they are, we can identify them and make sure they're running at the end of the day at the best running cost that it can possibly running. Some of the probably key factors we see wrong is probably commissioning, maybe the lack of commissioning, but also, as we just said previously, that handover. Unfortunately, especially in the new build side, they get handed to more than likely the housing team, and then eventually they find their way onto your end user. So it's not a direct handover to the end user, which is where we find the likes of the video assistants really well. But yeah, I think they're probably the two key ones for me on that handover. It's all about that resident, but for the new build stuff, it's making sure that the defects is looked at before it's out of defect period, because there's too many, I think, at the moment where it's just a little bit too late. And I would say 85% of our new build calls are for user error. So it's just total lack of knowledge. And it's just talking them through how it works. And that's so our engineer will get to site and we'll just run through the process, how it works, the type of system it is, and the controls. So I would say probably 85% of new build calls is user error at the moment.
So that goes back to Kevin's piece of early
Absolutely.
and really effective resident engagement about the changes in the heat systems. Brilliant. Thank you, guys. That's been really useful practical advice. We'll now turn over to audience Q&A. So I'm going to stop sharing my slides so I can see people.